Welcome everyone, this is Tisha Tari. In today's topic, we'll be talking about qualitative analysis. In this aspect of chemistry, we are going to run our knowledge about practical chemistry. So what we mean by qualitative, we're going to know about the quality of a substance or compounds. In this aspect, we'll be dealing more on SSC chemistry aspect of qualitative analysis. So in today's topic now, we'll talk about qualitative. What do we mean by qualitative analysis? Qualitative analysis is a systematic process of identifying unknown compound. And this compound contains two parts. It contains the cation and the anions. In this aspect, we'll be talking about salt. We define salt as a compound that is formed when all or part of the hydrogen of an acid is being replaced by a metallic ion or ammonia ion. So in this aspect, we have different types of salt. So the most important aspect we're going to discuss now, we now believe that each salt contains a positive and a negative side. For instance, let's use a very common one. We have sodium chloride. We said sodium chloride contains two parts. We said we have the positive sodium and the negative chloride form. So in this aspect, what we're going to identify now, if these substances or salt is given to us during examination, we'll be given a range of reagents for us to identify these cations and anions in our examination. So in this aspect, I'm going to put you through on how to identify this salt and how to analyze each of the salt. And this course will cover a lot of aspects of SSC chemistry, undergraduate courses, and so on and so forth. Welcome back to this page. So in this aspect, we are going to walk through this qualitative analysis. We have different steps in which we can undergo. This process can be well comprehended. So as I've defined, we define qualitative analysis as the systematic process of identifying unknown compound. So in this aspect, we'll talk about qualitative, we'll talk about quality of a compound, the quality of a compound. What we mean by quality, if we want to know the quality of any substances, let's say our sachet water, our bread, and so on, under the label, you notice that they wrote different substituents. They have chlorine, they have the sodium chloride is present, this one is present. They are telling you the amount in which those substances appear in such compounds. So in this aspect, let's use a sachet water. In sachet water, you will say sodium. Sodium have only 1 gram. They will tell you the breakdown of this nutrient in the water. This aspect of chemistry that deals with this identification of each of these components is known as a qualitative analysis. And this qualitative analysis follows a systematic process. In this aspect, you're going to run through salt in case of a SSC examination that is coming up. So we are going to talk about more about salt. So in this aspect, we're going to discuss the steps that are involved in qualitative analysis. What are the steps that are involved in qualitative analysis? In qualitative analysis, one of the steps is known as preliminary stages. So in this preliminary stage, when we say something that is the first step in identifying compound, we can use under the preliminary stage, we can use 3 steps. We can use the color, of the salt. 2, we can use the texture. We can use the texture. 3, we can use the smell. So for instance, now if someone is cooking at home, you can when you perceive such aroma of the food, you can actually detect. You can have a clue of what they are cooking. For instance, if you're cooking stew around your neighbor can identify that this guy is cooking something, this guy is cooking stew, this one is cooking rice, and so on and so forth. So we are going to use the color to identify the first stage in identifying this salt. A very good example that we can use color, we are told when we're teaching the periodic table, we said we have a 10 block in the periodic table known as the transition metals. So this group is made out of 10 blocks. We said the major characteristics of these 10 blocks is that they produce colored compound. They produce what? Colored compounds. So by this now, we can use this preliminary stage to identify certain group of salt in the laboratory. For a very good example, when we see a salt that have a color of blue, for instance, that has a blue color, we notice that this family of this compound mostly is from these transition metals. So a very good example, let's use a very good example. Let's use this color. Let's use this color. Let's have if you check this salt, you can see that it's blue. So this is a transition metal. We can actually believe that anything that produces a color salt is a transition metal. So in this now, anything that gives blue color, we can infer in the lab that it contains copper. Copper always give blue color. So if, for instance, you notice that a salt that is given to you contain a pure white or a colorless salt, it is more accurate that such salt do not contain these copper ions, do not contain these copper ions. So when you have a salt that contain yellow, we have green, we have light yellow, and so on and so forth. We can identify them using the preliminary stage. This preliminary stage, you're just trying to infer so that it can guide you on what to identify in such salt. So in this, you're not concluding that this salt contains copper or contain iron or it contains so, but you're trying to narrow your mind towards a specific ions so that you can have a direct identification. So in this, when you have a salt that contains yellow, that has something like yellow, it contains yellow. But let's use a very good example. Let's use this. If you have salt that contain yellow like this, look at this, that contain a form of yellow, you notice that this salt, I can infer that this salt contain iron. It contain iron. Iron can give this aspect, can give this kind of, it contain iron, and this iron we can have ion 3. So when it gives green, for instance, you can infer that anything that can give iron, I can infer that is very close to green. I can say ion 2 is present. So when you have light yellow, I can infer that this color is making reference to ion 3 as well. So in this aspect, the preliminary stage gives us a better idea on how this salt appear in our examination or in our laboratory. So a very good example that we can use color to identify certain salt in the laboratory. A very good example, we as I've said, we have the transition metal. We said one of the characteristics of transition metals is that they gives colored compound, or they produces colored compound, or they form colored compounds. In this aspect, whenever you see a blue color salt in the laboratory, there's a high tendency that such salt contain copper. So when you have yellow, you can actually infer that it contains ion 2, ion 3. So when you have a brownish salt, for instance, you can actually infer that such salt might contain ion 3 because it has oxidized from ion 2 to ion 3. So in this aspect, we can use these major characteristics to identify certain salt. We can use them to identify certain salt in the laboratory. As I've said, the color is very important in the laboratory as a primary stage of identifying these ions. So in this aspect, we're going to move to the next step, the texture. So we can use the texture of a salt, though we don't allow students to touch salt in the laboratory, but when you are using a web protective angle, you can be able to test this texture of this salt. A very good example by texture, something that you can touch and you feel how they appear. In this aspect, we talk about texture. This texture, we have some compound that are in form of powder. So we have some form of them that is form of crystal. They are in crystal form. A very good example of salt that is in a powder form, we have the carbonate family. We have the carbonate, we have the CO₃², and the hydrogen carbonate. C3-. In this aspect, the carbonate family, or normally, although it's not in every cases, most of the time they appear in a powder form, just like our powder with atom. So let's have a carbonate family. a carbonate family, let's have this. They're always in a powder form. They're always in a powder form. They are always in a powder form. So if you should notice this, you can see the salt. The salt is just like a powder atom. So we can use these characteristics to identify a carbonate family, where we notice that the salt that's given to us is a form of powder. So in this aspect, such salt contain what is known as carbonate family. It contains what is known as most time it contains what is known as carbonate family. So we have under the carbonate family, when you see calcium carbonate, sodium carbonate, and all the carbonate family, we say it first they can be identified with our naked eye using the texture when they are in powder form. When they are in powder form. So in this time, when we have a crystal, they always form in a crystal. A very good example is our common salt atom. You notice that when we mean by crystals, when you shine light through them, you can actually see a transparent the nature of that such salt. You can see light that is in form of star. They can reflect light. So in this aspect, when we say talk about the crystal, we said when we have the chloride family, the chloride family gives a better idea about the crystal, like the sodium chloride that we use, a common salt in our home. It is a form of crystal. We have the nitrate family. At the nitrate family, we said they have a crystalline nature. So we have the sulfate family, the sulfate family, the sulfate, and so on and so forth. This they contain what is known as they are in form of crystal. If they are in form of crystal, so in this aspect, let's have a very good example of this sulfate family. They are in form of a crystal. They are in form of crystal. Because of time, let's just move. We have, as I've said, the chloride family, they're in form of crystal, the nitrate, the sodium nitrate, the barium sulfate, and so on. They're in form of crystal most of the time. So I'm going to talk about the smell. We can use the smell to identify certain salt. In the laboratory, a very good example is the ammonium family. We say one of the characteristics of ammonium is that it gives what is known as it gives a shocking smell when you perceive such salt. If peradventure, if I should open the ammonia in this place, you have a shocking smell within the environment. So a major characteristic of this salt is that when you open the salt, when you perceive a certain stage, a certain smell that is shocking, we can infer that such salt contain ammonium ion. It contain ammonium ion. So these are the primary steps in which you can identify salt in the laboratory. So in this aspect, you have major characteristics of what to do. So after this step, you can carry on with your identification. But in sake of your examination, there are steps in which you can go through. So one of the steps in qualitative analysis is that you must ensure that each salt that is given to you is identified. For instance, now, during your examination, you'll be given a salt with an unknown name. The salt will be unknown to you. So during the exam, you'll be given a certain reagents. A reagent will be given to you, and so on, and the salt will be labeled, can be labeled with CN. So this CN, it means that this salt is unknown to you. So how can you identify this salt? Using the question that will follow each of these steps. So in this aspect, what are the steps in qualitative analysis? As I've said, one of the steps is preliminary stages. We'll talk about the color, the texture, and the smell. We'll talk about the other one is the confirmatory test by using each of these reagents. Each of the reagents will be provided to you by the examiner so that you can run through this identification using a specific reagents. And each of these ions, they are found, the changes in color or in state when these reagents are added. So in this aspect, I'm going to talk more about the confirmatory test. So we said this sodium, this salt we are going to identify, let's see sodium chloride. It has a negative and a positive. It's very, very clear. So in this aspect, I'm going to move directly to the confirmatory test. So for the sake of qualitative analysis, we we have a specific method through which we can report this idea in our examination. A very good example, we are going to use the table that is generally accepted in qualitative analysis. Here we are going to have a table. Here we're going to have the test. You have the test. We're going to have the observation. What did you observe? Observation. Here we are going to have inference. Inference. So in this aspect, a given test will be given. You tell the examiner what you saw or what you observed, and now you're going to make inference on certain characteristics. In this aspect, you're going to identify some of the cations so that you know how to go about this qualitative analysis. As I've said, this is a basic foundation for qualitative analysis. This class will be a very good foundation for those that are writing WAEC, that are going for just entering university, so that you understand these steps in identifying these ions. So you carry out these activities in your undergraduate 100-level courses, like the 102 in my school I graduated. So by then they're trying to test your knowledge on practical chemistries. This is the aspect of chemistry that actually gives you edge over others. So this now, a given test will be given to you, a given sort will be given to you, be asked to carry out this activity. For instance, now let's make reference to a very good question. Let's use the Cn. So say put Cn. Let's put Cn in a test tube. So this is a typical WAEC question. They say add 2 cm cube. This cm cube does actually mean you must add 2 cm cube. Add 2 cm cube of water. And test the solution, with litmus paper. So this is the first step. Say you should put Cn in a test tube, add 20 centimeter cube of water, and test the solution with litmus paper. This is the first step. The first step is that you should put the Cn. Let's bring out a common sort. Let's use a common sort here. Let's use a common sort. We have a So we said we should add like 2 ml of water. We'll now shake. We added a ml of water. We shake. You now observe whether this salt is soluble or non-soluble. So after this step, I will tell you the major characteristics of certain salt when they are dissolved in water. So you can see now, this salt. It is soluble. What we mean by soluble, that it dissolves in water. You can see it dissolves in water. We now say, under your test, we say Cn plus water. You said, in observation, we said the salt dissolves in water. So what is your inference? Anything that dissolves in water is soluble in water. Soluble salt is present. This is what you are reporting. So this is the first test. It said put Cn in a test tube, add 20 centimeter cube of water, and test the solution with what? Litmus paper. In this aspect, we say Cn plus water is what? The salt dissolves in water. Soluble salt is present. This is what you say. So this now, the Cn automatically have become a solution. We say solution Cn plus litmus paper. Now you'll be given a litmus paper, the blue and a red litmus paper. So they are going to run this test automatically. Let's use blue and litmus paper. Let's have a litmus paper here. Let's have a litmus paper. So let's choose the blue one. Let's see the characteristics of this salt in litmus paper. Okay, you can see it changes blue litmus paper red. Changes blue litmus paper red. So we're going to use the red litmus paper. Let's see the so it doesn't actually have effect on litmus paper. Anything that changes blue litmus paper red, it is known as acidic. It's known as acidic salt. So it turns blue litmus paper red to red. So we said since anything that turns blue litmus paper to red is acidic, we said acidic salt is present. So this is how you report qualitative analysis. In qualitative analysis, there's no need of you cramming or doing all kinds of forms of maneuvering, or you are trying to outsmart the examiner. It's what you saw during your reaction. That is what you are going to report. Whatever you are saying is what you are going to report. The essence is that for each of the table, you must tell what you are actually observed in these characteristics. If you check now, we said this gave us one. We said the solution when it's added with litmus paper, what is it turns? We say it turns blue litmus paper red. So what actually turns red litmus paper, blue litmus paper red is what? It's acidic salt. It's acidic salt. So in this aspect, you now say, let me just continue. We'll say divide the solution into three parts, to one, add ammonia in drop, and in excess, what did you observe? We say you should divide this solution into three parts. We are going to have into three parts. We have one. Let's have this. I'm coming. All right, we have divided the solution into three parts. We said to one, we should add sodium, ammonia in drop. Look at ammonia. So we are going to add it in drop. If we should add ammonia in drop, we're going to put just a drop. Okay. You can see now, ammonia in drop gave us a light blue PPT. In this aspect, what we mean by PPT is something is cloudy. You cannot see through the solution. It's cloudy a bit. So let's wipe this. You said when this say solution CN plus ammonia in drop. We can say this now. We can say light blue PPT present. What can actually give these characteristics? We can actually say zinc 2+, copper 2+, and aluminum 3+. Suspected. We are just trying to suspect this ions. So in this aspect, there's a characteristics of this sodium of this copper in ammonia. So if I should put this ammonia in excess, what would be the color? Automatically? We are going to, let's use a very good example. We said, let's look number here, 1, 2, 3. We said 3A plus ammonia in excess. What did you have? So excess. We said if we should add this solution in excess, what will it give us? If I should add it in excess, what will it give us? You can see now. So in essence, it gives us a deep blue PPT. A deep blue color is obtained. Deep blue color is obtained. So we said, yeah, we said deep blue PPT obtained. So the only thing that can give this color, deep blue PPT, when ammonia is added in excess is copper 2+ is confirmed. This is the only confirmation test for copper is confirmed. So these are the steps through which you can go through in identifying each of these ions in salt. So in this aspect, we're going to run through different analysis. We have been able to identify one of the cation. So in this now, let's move to a different salt that contain an anion, so that we can identify these steps. But generally, this is a step through which you can go through to identify these ions. It's a very simple step. As I've said, if we should recap now, we said one of the stages in qualitative analysis is that is the preliminary stage. With the preliminary stage, you can actually identify certain salt. You can use the color, you can use the texture, you can use the smell to identify them. We said one of the characteristics of the transition metal, which is the 10 blocks in the periodic table, is that they produce or they form colored compounds. So this will give us a better idea that any colored ions is obtained from this family, this 10 block, from scandium to zinc. Under that group, we say they produce colored ions. So we are going to talk about let's talk about another salt. Let's use a very different salt here. Let's talk about a different salt. Let's use a different salt. Let's use a different salt. Okay, let's use this. We're going to follow the same format. I'm going to follow the same format. Say we're going to follow the same step. We said put Cn. I'm going to take this one to be Cn as well. We're going to divide it into two. We're going to divide it into three parts. So that we can know different aspect of this analysis. Different aspect. So they follow the same format, but your ability to observe what you are trying to do is very, very important. So we're going to talk about, let's have this. We have solution. Let's use Zn. Solution Zn plus water. So we want to do observe. So it is soluble as well. It dissolves in water. You can say soluble salt is present. So we say we should divide this salt into three parts. This you follow the instruction that is given to you during your examination. So in this aspect, let's divide into two parts. Let's use two parts. Let's divide. Let's divide into two parts. Let's have this. Okay, let's have this here. We say to one, we should use litmus paper to test, depending on the direction of your question. So whatever you are asked to do, and please, whatever you're not asked to do during your examination, do not participate. Do not involve such a question in analysis. That means you're not following the blue litmus paper did not change. So let's use the red litmus paper. Yeah, we're going to have can see it changes the red litmus paper blue. So a substance that changes red litmus blue is basic. So we said solution Cn plus litmus paper. We said it turns red litmus to blue. We can say this is basic characteristics. Basic salt is present. Basic salt is present. So to one, we should say solution Cn plus barium chloride in drop. So what did you observe? So each of these reagents will be provided to you. I have a reagent here known as barium chloride. This is barium chloride. I will add it in drop. I'll add it. You can see now, when I add in drop or in excess, any of them, it gives a specific characteristics. It gives a white PPT is observed. White PPT is observed. When it is in excess or in drop, white PPT is observed. So what can actually give these characteristics? So we have the carbon family can actually give the characteristics. Carbonic family can give the characteristics. The sulfate family can give the characteristics as well. So these two family can give. One of them is that if you add ACl, when it dissolves, we say this compound is confirmed. So when you add ACl, this family, this PPT did not actually dissolve. We said this can be confirmed. So let's try now. If we should use a solid, let's say 1, 2, 3, 3A. We said 3A plus ACl, dilute ACl. So what did you observe? So if I should add dilute ACl, what are we going to observe? If you should have this now, let me just have this. If I should put it in excess, you can see now. You can see it's bringing out gas, like when you open a carbonated drink. So this now, it gives effervescent. Effervescent means a gas is given out. Effervescence is given out, making the solution to be clear. So a major characteristics of this family is the carbonate family. You can see the effervescent occur. Effervescent occurred, giving out unknown gas. You don't actually know the gas. Unknown gas. So what actually gives the characteristics is this carbonate family. So when a dilute ACl is placed in a white PPT, when it dissolves it and giving out effervescent, making the solution to be clear, this family is confirmed. This is the major characteristics of this carbonate family. So in this, as I've said, if you should see 3A plus dilute ACl and this PPT, this white PPT remain undissolved. When it remain undissolved, we say the sulfate family have these characteristics of making this not to be dissolved. So this is the primary stage of a qualitative analysis. It's a very systematic process, and interesting aspect of chemistry. Please pay a very good attention to this topic, and you try all you could so that you can know each of the steps and each of these tests and confirmation tests for each of these ions. So I'm going to give a brief solubility of this salt. Solubility of this salt in water. So we have the major. We can actually know certain salt in the laboratory that can actually dissolve in water. So I'm going to give you a clue on how to go about that. A very good method is when. So we said all sodium, potassium, and ammonium salt. They all dissolve in water. All chloride. We said all chloride ion salt, except silver chloride, lead chloride. They do not dissolve in water. So this is a very simple illustration. We said all tetraoxo sulfate. Except lead And barium sulfate, lead sulfate, they do not dissolve in water, except lead, barium sulfate, they do not what? Dissolve in water. So this is the major characteristics of this salt. Please, this will come to the end of this lesson. Please don't wait to subscribe to this page. So as you approach your WAEC examination, more of these questions and analysis will be coming to your way. And in our next video, we'll try as much as possible to discuss quantitative analysis. A quantitative analysis, you're just trying to measure the amount of certain substances when they react together. But in qualitative analysis, we'll talk about the steps in which these ions in the salt can be identified. Please, thank you for watching. Please do wait to share this video. Thank you very much for watching. Thank you.